Hey guys, how's it going? In this video, I'm gonna go through this Leetcode problem, pairs of song with total duration divisible by 60. So let's take a look at the question. So this problem was asked by mostly by Amazon, and I think it's a pretty good question. Um, the related topic is they talk about hash table. I didn't use hash table. I only use array. But it looks pretty efficient to me, and I'm going to walk through my solution to you guys. So let's take a look at the problem right now. So we are given a list of a song where the ith song has a duration time. So this is basically we are giving an array of numbers, and the number representing the duration of the song. So the first number representing the duration of the first song, and the second number representing the duration of the second song, and etc. So what we're going to do is to return the number of a pair of songs for which their total duration in seconds is divisible by 60. So for example, the first song lasts for 30 seconds, and the second song lasts the third song lasts for 150 seconds. So the two songs combined last for 180, and 180 is divisible by 60. So we get the first pair, and the second pair is comes from the second song and the third song. Oh, sorry, the second song and the fourth song. So basically, this one pairs with this one, and the total duration is 120, which is equal to 2 times 60. And so that's the second pair, and the third pair is comes from uh, the second song and also the fifth song. So the total duration is 60, which is equal to 60 times 1. I would like to go straight into an example to see how can we solve this problem. I'm going to do a dry run on Excel, and then I will put it as a code, so you know exactly what I'm doing. So we first look at the duration of songs. So the first row I'm having are the index, and the second row are the duration. So for example, the first song lasts for 30 seconds, which is exactly that, and second song lasts for 20 seconds, which is exactly the second spot over here, etc. And what we're gonna do is to take the modular of 60, as you can see the formula here. So basically, we take this element and then take a modular of 60, and the first spot I'm getting is 30. Second spot I'm getting is 20. The third spot I'm getting is 30. So basically, again, so this means 150. Take the modular of 60, and I get 30. So as you can see, I get, and then now we can look for pairs, right? And it's obviously the yellow pairs with the yellow. So as you can see, 30 pairs with this guy, and that basically means that is 30 pairs is 150. So we get the first pair. The second pair is look at 20, then compare with 40. So these two come to in a pair, and this one and the last one come into a pair as well. So in total, we have 3 pairs. So basically, we are looking for the complement. Basically, for example, 20, we're looking at the complement of 60 minus 20, which is 40, which is over here. And 30, you just pair with itself, which is 30. So how can we find the complement pairs? We need to have a modular count, which the index, as you can see, this is an array or a list. The first index is a 0, second index is 1, and it basically counts how many numbers that has a modular of, for example, 0, and it counts how many numbers has a modular of 1. So in this case, we have 2 numbers has a modular of 30. In that case, we go to the 30. The 30 is a 31st index, so it's going to be 1 plus 1. We have basically a count of 2, and we have a number that has a modular of 20. So we go to the 21st index, and add 1 to it. And then secondly, sorry, I don't need 1 plus 1, I only need 1. And the next one is a number has a modulo 40. I have 2 of them. So I'm going to go to the 40 first index. So we're going to have 1 plus 1 in here. And so now we can look for the complement. For example, if we look at the 21st spot and look at the complement, which will be 60 minus 20, which is 40. And if we look at the 40 index, so we found that is 2. So how many pairs we can do is we can go this number and this number. So basically we can go this one pairs with this one and this one pairs with that one. So in total, the number of pairs will be 1 times 2. So we have 2 pairs by having a number which has a modulo of 20. Pair is another number that has a modulo of 40. And because the way that we look at for complement is look at for example 1, and then look for the counterpart will be 60 minus 1. And so we don't have to do this again for the other half. Otherwise we'll be repeating our work and we'll be double counting. That's why we only need to do this amount of iteration to this modular count array. And also we have 2 edge cases where if the modular is 60, which means is the number or the original number is going to be 60, 120, and 180, etc. In that case, we don't have the counterpart the counterpart in anywhere else in the modular count can only be paired with itself. So for example, I have a number 60 and I have a number 120 or the number 180. So in that case, the pair can be only with itself. So for example, pair the 60 and 120, and that can be one pair. Second pair will be 60 and 180. That will be second pair. And the third pair will be 180, 120 and 180. This will be a third pair. So I have in total 3 pairs with all the numbers with modulo of 0. So by statistics, we can apply this formula. So we have n choose 2 because we look at for pairs. That's why r is equal to 2. And n is how many numbers in that spot, how many numbers with modulo of 60. So if we apply this formula, we can get, and then simplify a little bit in the math, and then we'll get n times n minus 1 divided by the 2. So n being how many number in that spot. Okay, and of course n has to be greater than 1. We have to have like at least one, more than one number to make it in a pair. Otherwise, one number itself cannot be a pair, right? And so that's one edge case. The second edge case will be the 30th index. Well, yeah. So in that case, we apply the exact same logic. For example, we have these 3 numbers. They are all of them have a modulo of 30, and we can find 3 pairs, right? So 30 pairs of 150, 30 pairs of 90, 150 pairs of 90. So we have 3 pairs, which is exactly the same logic over here. And we will apply the exact same formula over here. And it's going to be n times n minus 1 divided by 2. So that's so much on this algorithm. And let's put it in the code and how can we implement in Python. So first, we need to have a modular count, which is we have a 60 element, which is exactly this guy over here, right? This array. Okay. And after that, we need to iterate the time array. Okay. So for the time in time, this array, and we look at the index, take the modulo 60, and then we add 1 to the count. So basically what we are doing is to fill up this list, and then we have the access to the index, which is the time itself. Take the modulo 60, and then that become the index, and then we add 1 to it. So this is exactly how we can fill up this modulo count list. And then next, we are going to find some other pairs, okay? And also we find a complement. So let's take a look at it. And first, when we return it, we will return the answer. That's why we have the answer variable initialized as a 0. And so for the index from 1 to 29, so basically we are doing the yellow part in here, 1 all the way to 29 again. So the reason why we only do 1 from 29, we have 2 edge cases in here. We will deal with them separately, and also we only have to do 1/2 of it. Otherwise, we will be double counting, right? Because we automatically will find the next one by taking the complement, which is 60 minus itself. So let's do exactly that. We look at how many counts by accessing the index. Also, we look at the complement and taking the 60 minus the index. Also accessing to the modular count array times together, which allows us to find pairs added to the answer. This is how we go through all the irregular cases ranging from 1 to 29. And now we can deal with the 2 edge cases we talked about. So first, for the first index, where the modular is 0, which is exactly this one that we talked about, right? When we apply this formula. And when the count is equal to 1, which means that we cannot form a pair. It's only one element. That's why we don't add nothing to the. And actually, we don't even have to do this one. Do the answer plus 0, and just for illustration purpose, I just put it over there. And then we apply the formula, which is exactly that. Which is exactly this guy over here. And then we can do the same thing for the other edge case, which deals with the 30, right? Which is exactly this one over here that we talked about. And then at the end, don't forget to return the answer. Let's do that. I think we are all set. See, it's pretty efficient. And so let's talk a little bit about the time complexity. It's gonna be big of so we have a couple of for loops in here, but it's not so complex. That's why it's very efficient. So this one is a big O of n being of a number of elements. So we loop through the number of elements only one time. And when we access to the index, it's gonna only take the big O of 1. And this guy over here takes big O of 30, which is constant time. Yeah, and these 2 if statement takes constant time as well. So in total, it takes big over n, n being a number of elements. For space complexity, and we are being really frugal in here, we only need one more count to keep track of the 60 index, and which is a big over 60. We don't even have a in the hint in here. We also told that we have to use a hash table. I mean, we could do that, but to save a little bit of space, I didn't do that in this solution. So yeah, so this is my solution. I hope you like it. If you do, please like and subscribe. I hope this is helpful. Thank you so much for watching. I will see you in the next video. Thank you.